Well, let's move along. Good morning. Well, first of all, I'd like to thank you all for coming and also thank the organizers of this meeting today. The lineup is really looks great. Well, anyhow, I'd like to introduce myself. I'm Rafael. I'm the technology director of agru.com. I take care of the digital platforms, media, what we call publication platform that supports G1 and G-Show and all the identity management, the global ID. And today I brought here a topic to discuss with you, which is continuous delivery. And when I was preparing my slides, I kept thinking why this topic, continuous delivery, is so important. Why to talk about this? Well, I believe that there are a lot of buzzwords. People talk about the continuous delivery, etc., without even knowing what it means. Why to invest and waste time, or actually invest time to have an efficient continuous delivery process? And I decided to bring a story to tell you to help you understand the importance of this topic. I joined global.com in 2006, and when I joined in, there was a traditional development process. We had very well separated areas there. The creation department that developed and designed the products. That went to a development team that developed the idea, then a testing team, and finally to an infrastructure and operations team that put all these products to work. That was back in 2006. And we know that this model it is less efficient than, for instance, an agile development process. Then in 2007, we started to work with the agile development. We started to implement that in global.com. And well, the first change, the most fundamental change we went through back then was to take the UX team, testing and development teams, break up these departments and set up multidisciplinary smaller teams working with this on the scroll. And then we started doing this, and then we gained in efficiency to develop software, because of course, everyone working together there in smaller deliveries. I don't have to repeat here. It is much more efficient to the development process. However, the first challenge, or actually the challenge that came up on day zero, after we break these silos and set up the multidisciplinary teams, and those who have been through this must have lived through something similar, is that when we did that, the infrastructure team continued separate. So we had a big challenge, which was the development team was there delivering stores, functionality, delivering software to the customer at the end of the day, but the infrastructure team was apart, was separated, and we couldn't put things into production. We couldn't effectively deliver value to the end user. So we were there inside a development team, for example, delivering stories. And but this would not go into production. At the end of the day, they stopped at the infrastructure team, and they preferred, so to speak, to have a more controlled development production process. That is because at the time the goal of the teams were rather different. We had the development team, they had this goal of delivering stories, developing and delivering functionality, and the infrastructure and operations team was very much focused on stability, on making sure the production environment continued to work. So it was clear a challenge for us, a clear challenge. In other words, how can you break this barrier and enable the stories being developed there and the splints by the team to effectively come to the user and be delivered to the end user in a quick and fast way. And that inspired this break office development, how we break this barrier and bring them to this model of development, agile development, of continuous delivery of value to the customer. So from then on, Well, basically, we can see that the agile development requires a continuous delivery process. It is meaningless to have development teams working fast, delivering stories and functionalities, but not really delivering, because at the end of the day, this can be stuck in a change management project, and which is controlled by an infrastructure team that is not aligned with the agile delivery process. So continuous delivery is a basic need when we talk about a quick delivery of software in a quick and fast way. So this might be a one thing that cannot be broken, cannot be considered apart, to have a quick development without continuous delivery. And that is why it is important to have the continuous delivery process that truly works. And then I bring here an idea that's very important. I see that oftentimes people confuse this. Continuous delivery is much greater than continuous deploy. The idea here is to talk a little about this. What is this process when you talk about delivery, continuous delivery? Continuous deploy is part of continuous delivery, but at the end of the day, the continuous delivery process is actually an infinite process of development, delivery, and monitoring of functionalities of value to the user. That is, and this image summarizes this when we talk about development and ops. The What happens in infrastructure and operations area is to have what we should have is an infinite process of delivery, development, test, deploy, production, operation of what is in production, monitoring, and this serves as an input for improvements for a new planning, a new development. So, of course, you are always looking at the metrics to make development decisions. So, at the end of the day, this comes into an infinite cycle and in continuous cycle as well. So this might be the very essence of continuous delivery. The part of release and continuous deployment is only one small part of this all. But why? Well, we understand a little that this is part of the agile process. We want to continuously be delivering of value to the customer, to the end user. But why continuous delivery? It might be somewhat obvious for us. We are used to technology, but when you're going to implement a continuous delivery process, this requires a certain investment. You will have an investment of the team and time to build a pipeline in order to run this process smoothly in a continuous and automated way. So this requires effort, it requires work, and for us in technology, there's a trade-off between the effort and the benefit it will have with this process. Might seem obvious, but for those who are leading in this and are very much geared towards the business, this trade-off might not be so obvious. Maybe the trade-off between delivering functionality immediately or stopping to improve the continuous delivering process might not be so obvious. And then this was a question which for many years some people interested in understanding this. What is the advantage of having a continuous delivery process? They were very much, they spent a lot of time trying to understand this, and they did a great work. And most of my presentation here uh, it talks about this mapping work. What is the true value? What is the impact of having a continuous delivery process? How can you correlate, for example, a high organizational performance with software development processes and continuous delivery? And this is all in a book called Accelerate. At the end of the presentation, I will leave you with the references, but it truly summarizes all of this. It is a research study that was carried out as of 2013, interviewing over 30,000 technology professionals and ran an assessment in numerous organizations to try to understand what is the true benefit behind continuous delivery. What are the metrics that you can use to measure whether you're being efficient or not, and what are the practices that are part of this process? This is a little bit of what we will see here. Well, the first insight it brings is research shows that tech practices play a vital role to achieve high performance in an organization. So at the end of the day, this study brings together two things: software delivery performance, which is directly correlated to the organization's performance. And after all this study, they developed some methods which are behind this, which are methods very important. If you want to implement this in your company and you eventually might need to convince someone, these are figures that may help you gain time to invest in this. The first is that the high performance companies, they called here high performance in continuous software development, they grow 50% faster in terms of market share, in terms of company value, that is. And in addition, usually the high performance companies in software development, software delivery, they have twice more profit and twice more market share and twice more customer satisfaction in comparison with those companies that have a lower performance. And these are two metrics that are very strong. In other words, all this research is well based. It correlates. It makes a statistic correlation between the software delivery performance with the company's performance. So these are very strong arguments saying that it is worth investing in this high performance continuous delivering process. You know, that we are not doing this because it's nice for the customer. It is technology. We do it because it's fun. But oftentimes we want to we need to do it to generate results for the company. We work in a company, and the ultimate goal is to generate results and outcomes. So this reinforces the idea that it's worth investing in this. You will then get an outcome, profitable outcome. The company will benefit from this. And software delivery performance, what does it all mean? Well, it is a process of high performance continuous delivery. Well, the first thing to say is that it can be measured. You can measure whether or not you have a high performance in software delivery. And even more interesting is that in this study that was carried out, they found that the companies that have a high organizational performance and high performance in software delivery, not only they measure, but they measure it in a more complete and efficient way than those that have a lower performance. So this brings about another idea. It is important to use metrics to measure, to effectively measure what is being done, and be able to somehow measure your progress and be able to compare yourselves, with another company in the market. So in this study, they managed to correlate four metrics that they call those fundamental metrics, uh, which are highly correlated with the software delivery performance and consequently the organization's performance. So these are the four metrics: delivery lead time, delivery deployment frequency, mean time to recovery, and change fail rate. So I'll talk a little about each one of them. The lead time, delivery lead time, is the time it takes for the development to start a code, a functionality, and thus be into production. It is different from the traditional lead time that we are used to see in the agile development process, which is a broader metric. It starts before the process when the story enters the back line there. So we could measure it as well. well in a very objective way the time that it takes when the development team deliver the functionality all the way when it is ready to be delivered to the user. Deployment frequency is the number of times you can add more functionality and codes into production available for the user. Mean time to recover is the mean time it takes for you to recover from a failure in the production environment. For instance, you uh, added a function and there was a bug, it went into production and caused an unavailability, or it was not even caused by a specific bug, but some problem in the production line. How long does it take you to recover from that? And the change fail rate, which is the rate of production errors, so the rate at which or the rate of bugs and problems in production causing availability product problems. And then when we compare this metrics set between the high and low performance companies in terms of software delivery and organizational results, these are the findings. The high performance companies, they have a delivery lead time 106 times faster. They deliver deployment 208-fold higher in terms of deploys. They have a mean time to recover 2,600 times lower and a 7 times lower change fail rate. And there are sayings that if you follow these metrics and invest in a process to effectively optimize them, at the end of the day, it will have an impact on your development process, on your delivery performance, and consequently on the very outcome, financial outcome of the organization. And a question that I was working with, we had a meeting some time ago and I was talking with Martin, and he wrote the preface of the Accelerate book, and I asked him, well, so these are the four metrics. We should only look at them. These are the four metrics from the viewpoint of software development. He said, no, of course, these are four very important metrics that you have to look at when you are considering your delivery process, your process of being efficiency, having high performance, and eventually have a better performance for your organization. But these are not the only ones. Of course, there are other metrics that you might use that will help you to manage the development process, but these are four very important metrics that you should implement. And another thing he said is that when he heard about this, that through a statistically study, they correlated these metrics with the high performance of the organization and software delivery. They thought that this was meaningless, but then he saw that those who were the person doing this study was Jazz Humble, and he thought, well, if Jazz Humble is invested in this, it must be something meaningful. And then he started to study it, and he saw the value behind this, and this is what led him to write the preface for the book, the prologue for the book. And well, looking at these four metrics, we can then have an idea of how we are doing. However, an important point here that we have to discuss when you are trying to implement this and use and trying to collect these metrics and use this in your daily routine, is, these metrics should be collected automatically. That is the ideal situation, because when you have manual collection of metrics, you end up having some uh, people sometimes try to change the numbers and to have a better metric, and this is not the idea. The idea is to look at the metrics and have a true continuous improvement process in your team that will lead you to a more efficient delivery model, a more efficient development process. So always try to collect these metrics automatically. There are a number of tools that can help you do this, but there's another very important point when we're talking about metrics, which is Well, it is meaningless to take these metrics. Maybe the worst thing you can do is to take these metrics from your different teams and set up a ranking because you will be breaking the with the culture of the development process because at the end of the day metrics are to help the team. They are fundamental for the team to have a continuous improvement process so the team can look at the metrics and see how they can develop their own development process. The goal is not to have, for instance, to compare teams vis-a-vis performance because you will then kill the process. You will because people will try to change the process, will fraud the process to have better numbers, and you with that you kill your entire continuous improvement process. So this is a very important point you should pay attention to. And so I talked about the importance of metrics because, but how do we go about doing this? I'll show you how we do it. Well, what we want at the end of the day is to have a high-performance software delivery process, which involves two things. The very delivery of software and availability. If we look at the metrics, we're basically measuring these two issues: the speed with which delivery is being made, and also the availability in the environment, which is the time it takes for me to recover from failure and the number of faults I have.
This prompts a strong correlation between the organization's performance and software delivery. The continuous delivery process in itself will influence, as we said, these two aspects. Both the delivery of software, it is a developmental process, as well as my availability. And why is that? Because when I have an effectively working delivery process, I can add features and more quickly, but I can also recover more quickly. I can correct things more quickly without passing through a change management process and testing that will introduce any corrections to my product. It is an efficient, continuous delivery process, seeking better software delivery performance and high availability, in addition to the fact that this has an impact upon the culture of companies and provides real trust in people. When you're working transparently and effectively, people will feel safer. You don't have, for example, as we had earlier, the pressure of having a code in production. You had to do it at 3 in the morning because this is where you had the best audience and at global.com. You had to do everything in the morning, in the wee hours of the morning, which creates enormous pressure upon the developer. So you need an efficient process that will give you high visibility and high performance that will entail psychological security to people. And this will impact culture and indirectly also will influence the developmental process and the organizational performance. If you are people who feel more secure in what they're doing, that when they have the ability of correcting an error quickly, in fact, you will have people who are better prepared, who are more secure in yielding results to the organization. All this is very well and fine, but how do we get to this process of continuous high efficiency process? First, you need organized code. I mean organized code because this involves a number of aspects. ACP, an isolated, well-encapsulated code that you can code, that you can test effectively, that you can maintain effectively, and which is a code where a new person that comes into, that joins the team, can read and understand this code. So the architecture, software architecture, the manner by which you organized your application and your software is of the essence for a continuous delivery process. Because after all, if what it all boils down to, that it is going to be easier to maintain, and consequently, if it is easier to test, this will facilitate the continuous delivery process because you can have an easier test automation process. The second aspect is a coupling architecture. It is very difficult. I've seen this at global.com. It is very hard to get a monolith and make continuous delivery out of it. A lot, because you have so many features, so many dependencies that making changes there will impact a number of your product's features. For example, having a new code and not having it in production continuously in a great software monolith, the risk of impacting a number of features is very complicated. And also because for you to have a continuous deployment model for a monolithical culture is also very complicated because after all you cannot do progressive rollout or bug-free deployment. So having coupled architecture based on this will be a prerequisite for a continuous delivery efficient process. Another Another thing that impacts directly is monitoring. It is of no use to implement a continuous delivery per process, a CITT protocol, if you're not monitoring and understanding what is going on with the code that is being forwarded to production. When you gradually add a progressive rollout of a new feature in production, then you will have to measure and compare the metrics between the new and the old code in order to check what is the impact of this new feature upon the users and customers, and then make a decision of proceeding with the rollout or doing rollback. And today you cannot have a continuous delivery process that is effective in working if you don't have an effective monitoring system. Another issue that concerns this is having something that I call a trunk-based development. It doesn't have to be a trunk-based development. I think that the essential is to be able to work with small ranges. Imagine that you have a team that involves 6 people working in a single code base and some stories being developed in parallel. When you open too many parallel branches and you have too many stories being worked on in parallel, at some time you will have to merge the code. And those who have worked with many open branches, who has needed to do the merging, know that eventually you reach a degradation hell where you will not be able to integrate all the codes and the branches in your machine. And if you have branches that are long-lived, and let's work on a story that will create a branch, and then I create another story and work on the same branch, but then we have a branch that will last for 2 or 3 weeks, and then to merge this code will be very complicated. Since we're talking about continuous delivery, that is, to continuous delivery value in small amounts, small quantities to the end user, then we're talking about small bits of software. And the smaller it is and the faster you integrate this to the master code, the better it will be. And this will be non-existing lest you have a developmental model when you work with the short-lived small branches that will live for what, 1 day, 2 days at the most. And you're always integrated this in the master code. This is always going to production and yielding value to the user. This is rather obvious, isn't it? There's no way of doing continuous delivery without automation of deployment. There are several strategies. You have blue-green scheme that we use a lot. You can have a canary scheme where you add your codes, at small by small pace, and then increase gradually. Check whether it makes sense to increase or not, and then you can add to production unenabled the features that are gradually enabled. A number of strategies for a deployment process, and obviously the idea is that everything be automated. Since you merged your branch into the master, this will automatically create a test suite and continuous integration, and this will come into your pipeline and your integration that will take this code and give this to the end user, and depending on your strategy, you will have a number of ways of doing it. And there's a number of tools that will help you out. Netflix has a tool called the Cayenta that they use for cannery release and production research. At global.com, we use Blue Green, which is our TAS, and also worked very well. So there's this automated deployment process, which is a prerequisite for continuous delivery. And a continuous delivery process, integration, I mean, excuse me. And every time code is written, merger is done, you run your test suite and do automated integration tests. And for this, you have to be strong enough to and have tooling, nice test automation tooling. And I'm talking about unit tests only, but also integration tests, because oftentimes we're talking about a microservice architecture where you may have tens or dozens of systems working in an orchestrated manner. And this, in your continuous integration process, you have to add these integrations and guarantee the consistency of the main APIs, lest you do not run the risk of breaking down anything. These are the fundamental pillars of a continuous delivery process. For high performance, there are another three important aspects. The first is a clear change process. It is of no use to build the tooling and pipeline and CI/CD without a very clear process. And also simple. You cannot do a continuous delivery where you have super bureaucracy, where you have to open 50 forms, request 200 authorizations to forward anything to production. This will not work. It will have to be very simple. And the essential point is, if you implement well what is over there in terms of continuous delivering, you have monitoring and continuous integration and an automated deployment process. If you have all this all set up, you will have the security that if due to any change, a bug is incorporated in production, you can correct it easy because the process is going to be very well set up and optimized. Then what it all boils down to is that this will help you in the discourse. I need a strong change managed process where I need 50 authorization to achieve anything in production. If I can correct quickly, fine. If I have a bug run through and I can correct it in 5 minutes, I don't need 200 authorizations to do it. If it appears, we'll chop it down, and that's it. And so it is not enough to have the tooling and optimize the development process. The organizational culture and the part of the bureaucracy, the red tape involved has to be simplified, otherwise you won't be able to do it. And evidently you need a process focusing on availability. I think there's a major reference, which is Chaos Monkey from Netflix, which is a benchmark in test reference, where you will introduce errors in production environment, knocking down things in order to test the resilience and the high availability of the environment, of the ambience. So this is the reality where we want to increment and improve software performance. This is a simplified map. For those who wish, I have it in greater detail with more aspects and capabilities. It is in the State of the Labs report. It is a very good reference for presentation. What it all boils down to is that all this is implemented. We think all of this is very well and fine, and we often overestimate when we look at the whole theory and the materials and looked inside global.com. We wondered whether we really had a process, a nice, efficient software delivery process. Do we use all this? Can't we improve anywhere? And then we move on to real life. We did some very fine work with some teams in partnership with the Works in order to understand what is the participation of teams in software delivery. What are the current and future capabilities in terms of continuous delivery for each one of the teams. And we prepared an assessment with these 8 dimensions. I'm not sure you can read it, but basically continuous integration, guarantee, quality guarantee, setup, management, technical architecture, organizational architecture, and so forth. We mapped these 8 dimensions based on the framework that I showed you previously, the little map. And we added a few other things which at the time were important in terms of feasibility and organizational alignment, looking at the cultural aspects and not only at the technical aspects. We ran this, and its purpose was team self-evaluation. Nothing novel in this objective. It is not, we're not comparing teams. I think that any type of comparison there would yield wrong understandings. And the team who do the assessment, they will measure the 8 dimensions and make an evaluation, an assessment of their current moment, and a review of where they would like to be in 3 months' time, and a number of practices that they will adopt and implement in order to effectively reach the scenario that they seek in a 3 months future. So I took a team as an example, looking at the left. That is a team in light blue, the current situation. In dark blue, the situation the team wants to get to in 3 months and can be evaluated. And the team that does it, the current measurement as well as the evaluation of what they want to be, and they define their own actions. The process, it is a process of continuous team improvement. The team looking at where they are with all these practices, what they can apply now, what they cannot apply now. Perhaps it is much too complicated to do it now, but a continuous evolution process. On the right-hand side diagram, we compared it with a number of teams, and we found this assessment where we are the worst. The light blue is the minimum of all teams, and the dark blue is the maximum of all teams. This gave us some security in that if we look at it, there are teams that are really top in terms of continuous integration, in terms of technical architecture, and I can take the knowledge that is within these teams that are performing better, that have a better evaluation, and try and understand what they're doing, take this knowledge and take it to other teams which now have a worse evaluation, worse assessment. This is very good in terms of exchange of knowledge and practices between and among teams, which will entail a continuous improvement process throughout the company. Besides, in addition to this assessment, let us look at a specific case and try and, this is really elementary, try to deliver and check what we can do, what we cannot do, what are the difficulties. We took a case of a project that we call Smart RPG. Uh, I don't know who of you look at the demo play. You can return to the beginning of the program and request programming information. Take the global programming, inject this in our platform, and from this production grid, we can extract a number of information and yield a number of features. Smart RPG is this. It does exactly this. Takes the global programming and integrates it in the APIs where we integrate all this in global play. And earlier this year, we thought, well, let's have a self-contained project. We have a team of 4 people working on this. Let us try and implement and have this process up and running. And in 6 months, we were able to implement a number of practices, which, after all, created a fine result in terms of velocity or speed of delivery and software performance. And we worked, then we went on blue-green deployment, and then end-to-end availability, and then automated delivery, all the pipelines, all the tooling for deployment, and pre-production testing in order before effectively allowing this, making this available to the user. We have a model for trunk-based development with short-lived branches using QI in order to build the pipeline of continuous deployment. And again, this is small batches, small software batches, where we have self-contained packages that we can effectively make available to production quickly. And we left a model where we had this essentially in the direction, a model where we have a CI/CD pipeline implemented in ICI. That is, this is not complicated. All you need is focus. You don't have to stop the team and say, we're going to be here in 3 months working on this ICD, and in my continuous delivery process is delivering this software. I want to be right at the top of this continuous delivery. That is not the case. At the same time, you're deploying features you can slowly improve and build this process. This is not happening overnight, but in 6 months, for example, we're not talking about rocket science. Well, this is about the size of it. I brought the 2 main references that I mentioned in my presentation. And nothing to do with this book, but this is a very cool book. It mentions continuous delivery. Great part of what I showed here is in this book, and the State of the Work Labs report. There's a little link over yonder. Perhaps you can read it. Yes. Well, thank you so much. And this is our blog. For those of you who wish to learn more about what we are doing in software engineering and development processes, come there, access there, and I'm here available for questions. Thank you. Hi, Rafael. Good morning. You mentioned this transition of 6 months, more or less. But did you also have to require software, legacy software for a long time, old, and you had to maintain? And how did you get around this problem? Did you rebuild it? How does it work in this scenario of a long-time legacy? Good point. We obviously have an enormous stack of application, and evidently you're going to be in one of these scenarios. And when I was there, we had some of these cases, uh, great software monolith, and man, it was very difficult. It was plenty difficult. This is not easy to implement. And we tried to begin the migration and try to break it down in microservices and towards an architecture that would actually facilitate the process. And we had an easy case, which was of our media database, which was a great monolith where we had everything and people thought it was really chaotic. And we migrated to a new architecture that allowed us to implement a similar process. It isn't easy. Taking this monolith, trying to shatter it, and evidently you will shatter it and take smaller bits and pieces and try to isolate the things which are self-contained. This involved 2 years, 1 or 2 years. And the result at the end is quite positive because we never stopped. This is another issue. We have a legacy application. We can't do anything. I will have to rewrite everything. I won't deliver anything. This will not work either. This is why perhaps it took 2 years. At the same time, we were working on new things and adding features. We were rebuilding the thing and extracting some uh, pieces of the monolith and creating a microservice architecture. All this entailed 2 years, but the results were positive because we continued to deliver new things, and now we have a much better prepared architecture to implement this model. And we are now capable of having greater effectiveness and speed in delivering solutions. It is an investment that is quite worthwhile and will have to be made. We also play that. We also joke that it is software is biodegradable. If you're not evolving it, sometime it will melt down, and this is not something that we want. But it is an effort, and there's no way out. Rafael, congratulations on your presentation. In terms of kernel deployment, I am curious. I know that you have to assess who are the users who will get the new code, but is there any main point that you choose? And second is the monitoring. Does this monitoring have any tool, or is it just an open of customer incident? Well, as far as kernel release is concerned, when we began testing hypotheses and A/B testing, evidently this is associated to the progressive rollout of a few features. And we felt the need of developing an in-house solution. Because first, market solutions did not cope with the scale that we had, and it would be much too expensive. And some market solutions looked at some limited metrics. We wanted to look at a broader array of metrics. We were implementing ours. And the decision of how to do it, you can choose some manners, but we usually do a random raffling. That is, we may direct it, but it will depend on the type of feature that you're rolling out. Normally, we do this by a draw. We do a balanced sampling of by comparing the results. Otherwise, if you influence this very much, you will be creating a bias in one of these groups. And then we often try to create a random sampling and try to obtain some statistical relevance. As far as monitoring is concerned, we today have a monitoring stack which is very based in Graphan and works for it, among others. And there are things that we also develop, but the team itself oftentimes is responsible for developing the monitoring for applications. Obviously, since our scale is big, We have an infrastructure team that will build a basic monitoring stack where you can plug in and develop based on it. And I understand that the team itself, the team will develop it, they will have to monitor it, they develop the metrics, they look at the monitoring, and they have to follow up on software life cycle. I don't believe in this. There's a production problem, and somebody from operations will come around and solve it, because this fella does not know the context, and he will not solve anything except it's something very basic. Last question, please. Hello. I have a question which is not that technical, but I am very curious. You showed a slide with the metrics of delivery time and so forth, and you mentioned improvement. And I have two questions about this specific slide. What were you comparing in this improvement? What with what? And what are you considering as a high performance team? You were saying that what what high performance team do and their processes. Well, this is a process that was developed for this group. It is well detailed in the two references that I included at the end. When you say high performance and low performance, you're comparing organizations in terms of organizational performance in business terms, market capitalization and profitability and so forth. This is the correlation of high and low performance. If you take delivery lead time, the companies that have worse financial results will also have a software delivery performance 100 times worse in terms of lead time. So it is also based in organizational performance. My time is up, but in the report, I think it is worthwhile to look at it. Thank you, people.